If you see one of these, it's likely connected to the long arm of the law. Police have been using radar guns to nab speeders ever since the 1950s. They bounce radar off your vehicle and analyze the returning signal to get a reading. And that's when sirens wail and the officer says, "Do you know how fast you were going?" If you're a speeder, the police have probably got your number, thanks to the radar gun. When operated properly, radar guns boast an accuracy rate of plus or minus half a mile per hour. But of course, you can always try arguing with the officer. Making a radar gun starts with cable wire, lots of it. Rollers straighten it, then automated blades cut it to length and strip the plastic casing at both ends. With the wires now exposed, they're ready for the metal contacts that will allow wiring interconnections. A technician places the exposed wire in the contact, and a machine crimps them together. They then assemble wires in various harnesses. These connect to a power cable and communications port. The technician inserts wires into a plastic connector to allow them to easily hook into a circuit board later. This little gadget is a microwave transmitter and receiver. It sends radio frequency energy to moving vehicles and then receives it when it bounces back. The red wires being soldered to its posts will deliver power to it. The white ones will return the radar signals. This special plastic lens will focus the radar beam. She attaches the transmitter receiver unit to the funnel-shaped antenna at the back of the lens. Next, she solders wires to a circuit board. Some will carry power to it. Others will deliver the returning radar signals for analysis. This second, smaller circuit board will process power from the police vehicle to operate the radar gun. And an insulated metal plate shields the unit from interference from things like the police radio. The technician secures it with cable ties, and this radar module is now complete. She moves on to the display and control panel and snaps the keypad onto a little circuit board just below a light diffusing display window. She inserts the control panel hardware into a plastic faceplate and secures it with screws. As another safeguard against electrical interference, this plastic faceplate has been infused with metal. He wires the control panel to the power board to run a test. He checks all the digits and icons to confirm they display correctly. This machine presses melted plastic into the shape of casing for the radar gun. A static discharger worn on the wrist dissipates any static electricity from the technician's body. This prevents damage to sensitive electrical components, so it's worn throughout the assembly process. She links the two computer boards, ensuring a good connection because one will power the other. Then she installs the radar gun in the molded casing. She plugs the display assembly into connectors on one of the computer boards. Then she slides it into grooves in the casing. Now she hooks up this radar gun to a power source for a trial run. She taps the lens with a tuning fork. The gun responds to it as it would to a moving vehicle. If it functions properly, she installs the trigger switch. She closes the radar gun, securing the two-part casing with screws. A serial number and other identifying information goes on the side. In a final test, she connects the radar gun to a computer and aims the lens into a chamber. The chamber sends signals to simulate the effect of a moving vehicle, and the computer analyzes the gun's performance. You only have to look at a 35-year-old radar gun to see that this technology has come a long way, so it's ready if you try to pull a fast one.